Hey everyone, welcome back to my channel. Today, as part of our urban processes videos, we're gonna look into one of the most fun sources of urban movement data, which is shared bikes. This video is going to be the part one of a two-part series of urban shared bike systems, and in this series we're going to examine the temporal and spatial patterns of urban shared bike systems. Today we're diving into the temporal patterns. It's also something I like to call urban rhythms. Basically, we'll see the yearly, weekly, and daily mobility patterns of city bike trips. Every trip tells a story. When and how people move through the city can reveal so much about how New York actually works day to day. Morning commutes, weekend leisure rides, late night returns, all of these create repeating rhythms that define cities. Citibike releases monthly trip data, usually as zip files. So the first challenge is, how do we load multiple zip files from a directory and automatically merge them into a single dataset? We'll learn how to do that in Python using a simple loop, reading all the files and concatenating them together with pandas concat and creating one big data frame we can work with. Then I'm going to show you how we can eliminate incorrect and useless data. So we are going to see how a data cleaning approach might be in this sort of data sets. Once we've got that, we'll move into time-based analysis. We'll convert the start time column into a proper date time using PD to date time. That unlocks all sort of useful time attributes like DT hour and DT weekday, so we can explore patterns across the hours of the day and the days of the week. So as well as that, we're gonna use a rolling average, which is a simple technique that smooths out short-term fluctuations so we can see clearer long-term trends in an entire year in a time series. Then we'll group the data by hour and by weekday to see when bikes are more in use. Is there a morning rush hour spike? Does the usage drop midweek? Are weekends more about leisure rides? Today we'll have a pretty good sense of the temporal rhythm of New York City. When it wakes up, when it rests, and how its pulse changes throughout the week. All from Citibike trips. In part 2, we will take it further, shifting from when people ride to where they ride. We'll look into special patterns, popular routes, and maybe even map out some of the city's movement hotspots. So if that sounds interesting, make sure you stick around for the next video in the series. Let's jump into the notebook and start exploring city bike rhythms. Alright, so first we're basically taking an entire year of NYC bike share trip logs. And now we go into the documents, urban analytics, and we open a new Python file and we rename it as Citibike. Right after that, we go back to our folder and we move the zip files that we have downloaded from the website, and we keep clicking upload until all is uploaded. Then we go back to our file and we import some necessary libraries. We name the folder as 2020 Citibike trip data, and then this is a long code, but the idea is simple. For each zip file we open it, we find the CSV inside and we read that CSV directly into pandas. That's what this code is written for. This is our raw ingredient list. So once we've done that, the next step is to concatenate all the months using PD concat. And now we glued all of those monthly data frames into one giant data frame. So we have to call it back using PD read CSV, combined CSV. And once we've done that, we call it back into our file. So to look into what's in our dataset, we use .head, and it takes some time to load because it's a very big data set, but once it comes, we have multiple areas that we should consider, like for example the latitudes and longitudes, and started at, ended at. are these temporal data that we are going to use today. We look at the shape, and also D types are the data types that we have in this data set. So we have to fix some of them to be able to make these temporal analysis that we are intending today. So we are doing that by using the function pd to datetime, because right now timestamps are stored as plain text. We convert them into actual datetime objects, so we can do things like extract year, month, day, or calculate trip durations or plot trends over time. So once I converted both started at and ended at to pd to datetime, uh, the next thing to do is to check the minimum and maximum values that are associated with both of those. First of all, we are looking at started at, and we are seeing that there are some data that doesn't belong to there, like it belongs to 2019, so we have to go back and check. So now we really want to work on the data that belongs to 2020. That's why we're gonna filter out some spillover data that came to 2020 from other years. To do that, we are using dt.year equals sign 2020, so that we make sure that we have all trips that started in 2020. I do this for only the trips that started in 2020, and I decide not to do it for the trips that ended in 2020. We have a syntax error here. We fixed that. I think it's just a parenthesis. And then for one last time, we are checking the minimum and maximum values for started at, so that we make sure that all trips started in 2020. So it's just about copying the same thing and changing it to max, and then we see that all trips started in 2020, so no problems moving forward. Next thing we are doing is creating a filter for duration. We will calculate the trip duration in minutes. So what we are doing, we are subtracting the start time from the end time to calculate how long each ride lasted. Then convert seconds into minutes by dividing it by 60. And of course, this is just simple math, but it's super important because the duration tells us a lot about rider behavior. And of course, what this line does is just add a column called duration into our dataset as another column in the end. The next thing that we're going to do is that we're going to look into the minimum and maximum values in the duration column. So we want to see that because there are some extreme durations sometimes. It's due to forgotten bikes left undocked somewhere. So we have to get rid of these extreme values. We have to put a duration filter. And I think for this case, the best is to keep rides between 1 and 100 minutes. So we're gonna define a length for that and only keep values that fit our description of length. So what does that mean? That means our duration needs to be under 100 and over 1 minute. So we need to describe that accurately under length. So this gives us a clearer, more accurate picture of typical trips. This step is an extra sanity check. We need to do that so that we could ensure that our data is reliable. We keep only the ones that fit our length description, and then we check the minimum and maximum duration again just to check if everything is correct. I'm aware that I'm checking a lot of min and max, but Believe me, it's important to check every step that we see that our values are correct now so we can move forward. We can reindex our data and see if everything went smoothly, and it seems that it did, so we can move forward to the next line of code. Here we are starting some exploration with our data. First, just extracting the date. We separate the date from the timestamp, and this lets us group trips by day instead of worrying about hours or minutes. Next, we are counting the number of rides per day. So here's what's happening here. We reset the index so that each row has a unique index number. We use that index to count rides, and then we group by date. So the result table is gonna be how many rides happened on each day of 2020. We are doing this using a function called group by. So the dataset that we're creating here, daily rides, is grouping the dataset rides by date and aggregating the count of each ride made on that day. So let me tell you why group by is useful. Group by lets you split your dataset into groups based on some columns and then apply some calculation to each group and then finally combine the results back together. It's absolutely one of my most used functions, so it's good to know how that works. So daily rides, we said head 30, which means that we are seeing the first 30 lines of data, and we have daily rides for the 30th of January. So next we are plotting the daily ride count, and this line that we are writing lines a plot of rides per day. We are using a figure size of 17 by 7, and then we are plotting using matplotlib, using daily rides, date versus daily rides, ride count. We are also looking at labels. Our labels are going to be the date for X, and then not date but days in particular, and for Y label we're gonna have the ride count for each day. So let's write plt.show and see how the line chart comes up. So we have a pretty jagged line here. That happens because the daily data has always some noise because of the weather or holidays, and in this case, COVID lockdowns as well, seasonal changes. So next we need to smooth this out. And that's why we're going to compute a 15-day rolling average. A rolling average takes the average of the last 15 days or whatever days you are defining. It could be 30 as well, sliding through the year. So this smooths the plot and reveals the real trend without all the daily up and down noise. So here I realized that I have a problem because I forgot to write the rolling. So let's fix that quickly. Now it's fixed. We can move on to the next lines of code. Here there's another important step. We need to trim off the first 15 rows and the last 15 rows of the dataset to remove the NAN values created by the 15-day rolling average, leaving only the valid or smoothed data. So here using the function ilog, we are defining the first 15 and the last 15 rows so that we're only left with the data that has some values on it. We are seeing the column MA here. That's what we're going to visualize next. It's the rolling average for the entire year except the first 15 and the last 15 days. Again, using the same principle, we will create a figure 17 by 7, and then we will plot the daily rides by date, so the days on the x-axis, and we will plot the MA on the y-axis. We are using a different color here. Let's choose crimson, just for the sake of difference, and seeing another color plotted on Matplotlib. For the labels, we are writing days, and for the Y label, we are writing the right number again as in the previous one. So let's see how the new chart comes. Hopefully it's much more smooth, and it is. It's smoother. We can see ups and downs very clearly, especially how the usage dropped around March 2020, which was the worst of COVID. Now next we are jumping onto something totally different, analyzing weekday patterns. So we're gonna extract the weekday name first by using dt.dayname. So what this function allows us is it creates another column called weekday, and for every single row we have Monday, Tuesday, Wednesday, any day of the week. We can check with .head and we are seeing the last column dedicated to weekday. So then after that, we're gonna create a weekday order, which means that we want our weekday to start by Monday, and then go like Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. We are creating a sort of a list that ensures that. Having this step is important because if we don't do that, we don't have a bar chart in the order of the days of the week that in the way that we want. So we want to ensure that. Then we start weekly to group by weekday and membership type. This will compare annual members versus casual riders across each day of the week. So having that will allow us to see how members and casual riders have different amounts of daily bike routes over the week. And also we want to unstack and reindex in the weekday order so that we have the weekdays in the order that we want. So then we look at into weekly, and we see the numbers by casual riders and member riders. We see that member riders are much higher than casual riders. Then of course we want to plot this. We plot it as a bar chart, and it usually shows the members ride more on weekdays, and we can call them commuters, and casual riders spike on weekends, tourists or leisure. So to be able to see this difference, we are naming the title of this plot like a weekly activity, member versus casual, and we are plotting it. Again, the same principle. We are using X label as day of the week this time, and we are defining the Y label as the number of trips. We are going to use something new this time for the sake of being more, having a more presentable bar chart. We are using rotation, and it will rotate our labels by 45 degrees. And we are entering a legend as well to differentiate the rider type, member versus casual. We are saying plt.show, and for the members we have a lot of use over the casual riders. We can see that the casual riders are a little bit more spiky on the weekends, but not as much as regular riders. So our last analysis will be analyzing hourly patterns on weekdays, only on weekdays. So the first thing we are doing, we filter out weekends. We are using this code for that, and then we are also using dt hour to create every hour that's associated to every of those weekdays. So dt hour is also useful because it will pick the timestamp and only take out the information of the hour that is attached to it. Once we've done that, we group by hour, and it's another step that uses the group by function that we've used before. Now here we will group by the hour and extend it not by the count that I do here, but size is better. I change it afterwards. So I am doing pretty much the same thing for plotting. The lines are not so different from each other. So I will use this time to tell you what I think about this little study that we've made together. The final plot that we're gonna see is a line chart that shows the daily rhythm of weekday riders. There is a big morning spike, obviously, because people are biking to work, and there will be also an evening spike. That means people are heading home, and there will be significantly lower activity overnight. So it's pretty much the heartbeat of a city for those who are using bikes to go to their jobs. I will fix a couple of errors that I think I did before, like changing the count to size, and I will return to that once I finish writing those codes. But here's the full walkthrough. We started from raw zipped trip logs and cleaned them up, filtered them, calculated ride durations, and built visualizations that reveal daily usage trends, smoothed long-term patterns, weekday versus weekend behavior, members versus casual rider differences, and hourly riding routines. That's a full year of NYC mobility packed into one dataset. That was very fun to do all this. Thanks for joining me, and see you next time, where we're gonna tackle the spatial patterns of the same dataset.